Dear learners, I am Dr. V. Venkatramanan, Faculty, School of Interdisciplinary and Transdisciplinary Studies, IGNOU. Today, we will be discussing about climate change, which is an important challenge to sustainable development. And this is very much part of global challenges to sustainable development. To start with, the climate change is not uncommon in the Earth's history. Nevertheless, the fifth assessment report of Intergovernmental Panel on Climate Change stated that warming of the climate system is unequivocal, and since the 1950s, many of the observed changes are unprecedented over decades to millennia. The atmosphere and ocean are getting warmer with every passing year. The amounts of snow and ice are on decline. Sea level is on rise, and the concentration of greenhouse gases is increasing tremendously. Human activities are estimated to have caused approximately 1 degree centigrade of global warming above pre-industrial levels, varying from 0.8 degrees centigrade to 1.2 degrees centigrade. The global warming is likely to reach 1.5 degrees centigrade between 2030 and 2052 if it continues to increase at the current rate. The climate change influences all the components of the biosphere. So today we will be discussing about climate system and the drivers of climate change. Climate is a statistical measure of the state of atmosphere in terms of meteorological variables like temperature, rainfall, humidity, etc. for a particular region for a period of time of more than 35 years. The climate can fluctuate on short time scales, producing, for instance, the hydrological drought, and over much longer time scale, giving rise to glacial epochs. The United Nations Framework Convention on Climate Change defined the climate system as the totality of the atmosphere, hydrosphere, biosphere, and geosphere and their interactions. The climate system evolves in time under the influence of its own internal dynamics and because of external forcings such as volcanic eruptions, solar variability, and also anthropogenic forcings such as the changing composition of atmosphere, particularly the greenhouse gases and also the land use changes. You can see from the schematic presentation that the climate system is powered by the solar radiation. Since the Earth's surface temperature has been relatively constant over many centuries, the incoming solar shortwave radiation SWR must be nearly in balance with outgoing long-wave radiation LWR. About half of shortwave radiation is absorbed by the Earth's surface. About 30% of shortwave radiation is reflected back to space and 20% of shortwave radiation is absorbed by the atmosphere. The LWR, that is long wave radiation emitted from the Earth's surface, is largely absorbed by the radiatively active gases which are popularly called as greenhouse gases like water vapor, carbon dioxide, methane, nitrous oxide, and other series of greenhouse gases. The downward directed component of this LWR, that is long wave radiation, hits the lower atmosphere, and this process is popularly called as greenhouse effect. The climate system is a dynamic system. It's a very complex system, and it is in the process of in temporary balance. The changes in the climate system, either due to the natural and anthropogenic reasons, can perturb the Earth's radiation budget, resulting in a radiative forcing that affects the climate. The forcings can be construed broadly as external and internal forcings. The external forcing refers to a forcing agent outside the climate system, outside any system for that matter, causing a change in the climate system. The galactic variations, the orbital forcing, orbital variations, and solar forcing or solar availability, the solar intensity, or external forcings. On the other hand, the processes intrinsic to the earth and its atmosphere also alters the climate. These internal forcing factors include orogeny, that is mountain building, the distribution of land masses, volcanic activity, and increasing greenhouse gas concentration, and the chemistry, chemistry of atmosphere, and also the surface reflectivity. Let me start the discussion by defining the term climate change. The climate change is the variation in either mean state of the climate or in its variables, the climate variables, persisting for an extended period of time, typically decades or longer. It includes the temperature increase, which we popularly call as global warming, changes in precipitation pattern, the sea level rise, and increased frequencies of extreme weather events. Further, the climate change follows a specific pattern of change in climate or its variables over the time. The climate change may be due to natural processes, internal processes, or external forcings such as modulations of the solar cycles, volcanic eruptions, and persistent anthropogenic changes in the composition of the atmosphere or in the land use. Very importantly, the United Nations Framework Convention on Climate Change defines climate change as a change of climate which is attributed directly or indirectly to the human activity. It's a very important point. So, a change of climate which is attributed directly or indirectly to the human activity that alters the composition of the global atmosphere, and which is in addition to the natural climate variability observed over a comparable time period. On the other hand, the climate variability refers to the sudden and discontinuous seasonal or monthly or periodic changes in climate or its components without showing any specific trend of temporal changes. So, the variability may be due to natural internal processes within the climate system that we call as internal variability, or to the variations in natural or anthropogenic external forcing that we call as external variability. Now, let us see how climate change can be viewed in terms of statistical measures like mean and variance. For any climate variable that is stationary, the statistical measure can be represented as a bell-shaped curve. The peak of the curve, the peak of a bell-shaped curve provides the mean, and the width of the bell-shaped curve represents the variance. So, let us take the temperature as a climate variable. You can see from the graphical presentation that if the climate undergoes a warming without any change in the variance, then the bell-shaped curve moves towards the right. The consequences of a shift to higher mean is that there are fewer cold days towards your left, fewer cold days and more hot days. See, on the other hand, if there is an increase in the variance but there is no change in the mean, in that case the bell-shaped curve will be more fatter or it will be lower. So, in this case there are more cold and hot days. In case of both mean and variance, if it is increasing in both mean and variance, if it increases, then there will be more frequent hot days, hot weather. So, that is the key thing of climate change and climate variability. So, we need to manage the variability. It is more it's a great challenge indeed. So, now let us discuss about the drivers of climate change. As regards the drivers of climate change, it is necessary to attribute climate change either to natural causes or human influences. Nevertheless, it is indeed a challenge to attribute the causes of climate change because the climate system is very, very complex. Additionally, the natural causes are overlaid by the human induced causes, and also the natural causes of climate change prevail over a very long period of time. So, in essence or in effect, the climate system is influenced by factors either internal or external to the system. So, the factors external to the system are called external radiative forcing, which includes solar variability, the astronomical effects, the tectonic processes, the movement of land masses, and that we call as tectonic processes, and volcanic eruptions. However, since the Industrial Revolution, human activities are more responsible for causing climate change. The important natural drivers of climate change in the industrial era, during the industrial era past two or three centuries, if you look at it, are the changes in the solar irradiance, the volcanic eruptions, and the phenomenon of ENSO, El Nino Southern Oscillation. However, there are other known natural drivers of climate change which operate on a longer geological time scales. The anthropogenic drivers include mainly the changes in the greenhouse gas concentration, the changes in the land use, changes in the aerosol concentration. So, the natural drivers of climate change include the solar variability, the orbital variations, the tectonic processes, and volcanic eruptions. Let us see one by one. The first and foremost important thing is the orbital variations. The orbital variations or Milankovitch oscillations, it's popularly called as Milankovitch oscillations, throw light on the timing of the coming and going of the ice ages and interglacial epochs. The changes in the orbit affect the amount of sunlight. That's a very important thing. And very important thing, that is the amount of sunlight that is striking on the earth, as well as the distribution of the sunlight both geographically and seasonally. Primarily, there are three important orbital cycles. They are eccentricity, obliquity, and precession. The shape of the Earth's orbit oscillates from elliptical orbit to more nearly circular orbit with a period of 1 lakh years. That is called as eccentricity. On the other hand, the Earth's tilt angle, every one of us know the tilt angle with respect to its orbit fluctuates from 21.5 degree to 24.5 degree with a period of 41,000 years. It's again a very important thing. This we call as obliquity. There is a 23,000 year period associated with the wobbling of Earth. This is called as precession of the Earth's spin axis. The past global temperature records show a primary cycle between the glacial episodes of about 1 lakh years mixed with the secondary oscillations with periods of, rightly said, 23,000 years and 41,000 years. So in a way, the records prove the fact that there is Milankovitch oscillations are taking place, and this Milankovitch oscillations sync with the changes in the temperature in the past. So the orbital variations change the total amount of sunlight only by about 0.1%. Its influence on the global heat distribution is highly significant. This is a very important point. Though the variation is around to the tune of only 0.1%, but it is more significant because it can cause a change in the climate. So in that sense, these natural drivers, particularly the orbital variations, are very, very important. As regards the solar variability, the periodic occurrence of sunspots influence the solar intensity. During peak periods of magnetic activity on the sun, the solar intensity, the solar surface has a remarkable number of darker and cooler region which is very dim in nature. These are called as sunspots. And while the sunspots block the solar radiation, the surrounding area, the faculae, are brighter than the surrounding surface. During the periods of increased number of sunspots, that's a very important thing. So during the periods of increased number of sunspots, there is an increase in the solar intensity. So the sunspot cycle causes around 0.1% variation in the solar radiation reaching the Earth. This variation in solar radiation can bring a change in the Earth's surface temperature by an extent of 0.2 degrees centigrade. The solar activity affects the climate on the earth. It's a very important point actually. In fact, if you look at the past, the little ice age between the year 1630 and 1850 is believed to have been triggered off due to the decreased solar activity. Further, it was reported that about 3 billion years ago, it's very past 3 billion years ago, the solar radiance was only about 80% of the present value. It's a very important point. The next one is, as far as the natural drivers are concerned, the tectonic processes. These tectonic processes are equally significant. It's very important as far as our understanding about climate change is concerned. When you look at the events on the Earth's surface on geological time scale, you can find that the position of continents and oceans have changed due to the Earth processes. The science dealing with this particular movement, a study of this movement of land masses and also the ocean bodies, we call it as plate tectonics. These movements of lithospheric plates have caused formation of mountains, which we call it as orogeny. And this is a very important thing, and this has caused the changes in the mountain ranges also, the sizes and the plateaus. Think about the Himalayan ranges, the Tibetan plateau, everything is because of the movement of plates, lithospheric plates. And this movement of lithospheric plates are related with the climate change. The tectonic processes have also influenced the atmospheric circulation pattern, and also the ocean circulation. It was reported that the ice age episodes such as the Permo-Carboniferous glaciation of Gondwana land were due to the changes in the continental location. It's a very significant point. Also, the desert conditions observed in the western part of the China and the Central Asia was attributed to the uplift of the Himalayan ranges. I was just talking about the Himalayan ranges and also the emergence of the Tibetan plateau. So, the tectonic processes are equally important, like the solar variability, the solar irradiance and so on, so forth. The next important point is the volcanic eruption. Yeah, it's again a significant point as far as the causes of climate change are concerned, and this is a natural driver indeed. The volcanic eruptions are also an important cause of climate change. As I told you, we can see with a lot of examples. Volcanic eruption, due to the volcanic eruption, large amounts of sulfur dioxide, it's a very important gas, sulfur dioxide, water vapor, ash and dust particles are thrown up into the atmosphere. The tiny ash particles and also the dust particles form aerosols in the atmosphere, which reflect the solar energy back into the space and have a cooling effect on the planet. And it's a very significant point as far as we are talking about the climate warming or global warming. These small little particles, the aerosol particles like the sulfur dioxide, and these all forms kind of an aerosol particles which can reflect the solar energy or solar radiations back into the space. And it's a very important point we need to take into account for further study of climate change. So, coming to the anthropogenic drivers of climate change, the human beings are paramount. Their actions, their deeds, and if you look at it, it's so much important that we call the present era as Anthropocene era. Human beings influence the global environmental change so much so that they can bring anything possible on the landscape. Think about the agricultural activity. 40% of the global landscape is under agriculture. It's because of human activity. The similar is the case with the industrial activity, similar is the case with the urbanization and so on and so forth. And this kind of human activities bring in a lot of changes, and that changes we call it as global changes. That's global environmental change. And within that global environmental change, one important change is the climate change. That's what we are discussing right now. So, the changes in the atmospheric composition, I am talking about the greenhouse gas emissions, the land use or land cover changes, and the changes in the aerosol loading, aerosol particles in the atmosphere, are few striking variables that are linked to the human activities. And these changes are responsible for bringing in a change in the climate system. The increase in the greenhouse gas concentration and other changes in the terrestrial ecosystem endeavor to increase the radiative forcing. That's a very important concept indeed. and also the global temperatures. So the first and foremost important thing as far as the anthropogenic drivers, or in other words, to decipher how the human beings can bring in a change in the climate system, the foremost important thing is the atmospheric composition, the greenhouse gas composition. Straightway, if you look at it, the post-industrialization increase in the concentration of greenhouse gases are mainly due to the human activities. The extent to which each greenhouse gases perturbs the climate system over a particular time period depends on the concentration of the gas in the atmosphere and its radiative forcing. The largest contribution comes from the burning of the fossil fuels, mainly for the purpose of transportation, heating and cooling of buildings, and also the industrial application. There has been a remarkable increase in other radiative gases also, like methane, the nitrous oxide. It's very important if you look at it in the past few centuries. Their increase during the past 4 decades has been at least 6 times faster than it was observed over the last 2 millennia. So in fact, the human activities are estimated to have caused approximately 1 degree centigrade of global warming over the pre-industrial levels, with a likely range of 0.8 degrees centigrade to 1.2 degrees centigrade. It's a very important repercussion of human activities, because we were in a position to bring in a change in the climate, and that too to an extent of an increase of 1 degree centigrade of global average surface temperature 1 degree centigrade. It's a very significant increase. So the second important point is the changes in the land use. I just rightly talked about that how human beings can bring in a change in the land use. So land use may be changed for various reasons, including but not limited to urbanization. It's a more important activity. Agriculture, yes, and industrialization. These changes bring about changes in the land cover, the most visible and important of them being the deforestation. So this kind of land use changes impacts the rainfall pattern, the soil pattern and land degradation. It's the ultimate end result of all human activities, particularly the land use changes. Also, the deforestation influences the climate through changing the atmospheric composition and influencing the water cycle, the hydrological cycle, and that is the most significant aspect. When you remove the vegetation from the Earth's surface, that can affect drastically the water cycle. So with that, I'll conclude this session. We'll have the next session on climate change part 2, wherein we'll be discussing further nuances of climate change. Thank you.